All right. So, Trig lecture 419 and 20, the student will use elimination method, or back in the Stone Age we called it linear combinations, to solve word problems involving systems. This is actually Algebra 2, but we didn't get a chance to cover it last year because of COVID, so we're going to take a look at it today. Excuse me. We're going to use the 6 steps. We solved systems last year, we just didn't do it using using the method to solve word problems. So the elimination method is a review of what we talked about last year. We're going to make the coefficients of either variable exact opposites by multiplying. We'll then add the equations together. That'll give us a single variable which we'll solve for. We'll then substitute that into any equation as long as that equation has 2 variables. Then we'll solve for the other variable, so we'll have solved for 2 variables. And then we'll answer our question. We'll put the numbers that we found in the context of the question. So I'll be referring to these as I go. You can scroll back the lecture and see what I'm talking about. I'll probably scroll up and down as I'm going just to point out which step I'm on. So here we go. This is solving little word problems that form systems. System is just 2 equations at the same time, or more. The school is selling tickets to the talent show. On the first day they sold 6 adult tickets and 7 child tickets for a total of $94. On the second day they sold 6 adult tickets and 5 child tickets and took in $74. What's the price of one of each ticket? In other words, how much does a child ticket cost? How much does an adult ticket cost? So here's one way of doing this. You can probably figure it out in your head, but here's how, if it was really complicated, here's how we would do it. I'm going to call adult tickets A and child tickets C. I'm going to just pick a variable for them. I'm going to say 6 adult tickets. 6 adult tickets plus 7 child tickets sold for or adds up to $94. And I'm going to read on, and it says the second day they sold 6 adult tickets and 5 child tickets, and those sales totaled $74. And now I have a system. That's 2 equations, and I want to solve it. So I'm going to follow those steps that I just talked about up there. I'm going to make the coefficients of either variable exact opposites, and I like to find the easiest one to do, but it doesn't matter which one you pick. But I want to make them exact opposites using multiplication. I see that I could multiply that by -6, and it would be the exact opposite of that. In order to multiply this by -6, I've got to multiply every term in this equation by -6, so the value of the variables doesn't change, just the way the equation looks. We can multiply anything we want on both sides of the equation, and the equation will still hold true. That's the multiplication property of equality. So that's what I'm going to use. Or I could multiply this one by -5 and this one by +7, and that would turn that into -35 and +35. So I can do either one of those things. I'm going to do what I think is easiest and multiply this one by -1. I've also got to multiply this -1 by everything else in this equation. That way the values of the variables don't change. So this is -6a minus 7c is equal to -94. There, that's step 1. Make the coefficients of either variable exact opposites. I chose to make these exact opposites because it's just a little quicker. Step 2 says, add the equations together. And when I do that, the exact opposites will disappear. 6a plus -6a is 0a, which is 0. 5c minus 7c is -2c. 74 minus 90, whoops, that's not a -90, yeah it is. I'm adding, 74 minus 94 is -20. Confused myself for a second. Okay, so what I've done so far is the first 2 steps. Make the coefficients of either variable exact opposites by multiplying. And that means we're going to multiply both equations by something until the coefficients of either variable are exact opposites. Step 2, we added the equations. Now we're going to solve for the single variable. Here I'm just going to divide both sides by -2. So I divide that by -2 and divide this by -2. This gives me C is equal to negative divided by negative is positive, 20 divided by 2 is 10. Now I'm at the step up above that says substitute this into any equation that has two variables. In other words, I don't want to plug it in here. That's an equation, but it only has one variable. But I can plug it in as a C value here, here, or here. And I'm just going to pick one. I like that one because everything's positive and the numbers are a little bit smaller. But you can plug it into any of them and you'll get the same answer if you don't make an arithmetic mistake. So I'm plugging this value in right here, and I'm going to call that 50. 5 times C is 5 times 10. So when I rewrite this, 6A plus 50, 5C is now 50, 5 times 10 is equal to 74. So I've substituted this into any equation that has two variables, and now I'm going to solve for the other variable. That's the step I'm on right now. Substitute the value from step 3, where we solve for the single variable, into any equation that has two variables, then we solve for the other variable, which is where I am right now. I'm going to subtract 50 from both sides and then divide both sides by 6. So let's do that in our heads. If we subtract 50 from here, this turns into 0. 6A plus 0 is 6A. If I subtract 50 from here, that gives me 24. 74 minus 50. And now I'm still solving for the single variable. I want to get rid of a multiplied 6, so I'm going to divide both sides by 6. If I divide 6A by 6, I get A. If I divide 24 by 6, I get 4. So that is, unless I've made a mistake, the cost of an adult ticket. Okay? Now I'm going to plug this in. Oh no, I've got it all solved. A child ticket is $10. And an adult ticket is $4, so I'm going to go ahead and state that because it said, what is the price of one of each ticket? So I want to go ahead and state adult, $4, child, $10. Little kid's got to get out there and get a job, I guess. She's kind of backwards. But there we go. I followed those steps, and that's what I got. Let's see what the answer key says. Says adult ticket $4, child ticket $10. Yay! Okay, so there's how we do it. We take a little word problem that involves a system, and that's just two equations, and then we use, in this case, we're going to use the elimination method. These 6 steps will let us arrive at the correct response here. Let's take a look at it. Judy spent $72 on 3 rose bushes and 5 pots of ivy. Matt spent $18 on 1 rose bush and 1 pot of ivy. What is the cost of 1 rose bush? What is the cost of 1 pot of ivy? Basically the same problem as above, but the numbers are different. So let's take a look at what we got. $72 was spent on 3 rose bushes, so I'm going to say 3R, plus 5 pots of ivy, I'll just call it P, 5P, is equal to, you can use any variables you want, but I like them to kind of remind me of which one I'm talking about. Pots of ivy, roses. And that's going to be $72. There's one equation, yay. Matt, he spent $18 on 1 rose bush. You can call it 1R, or you could just call it R. If you just call it R, there's an implied 1 here. 1 rose bush and 1 pot of ivy is $18. What's the cost of each? Let's see. I'm going to follow those steps. I'm going to make the coefficients of either variable exact opposites. So I'm going to multiply this one by -3, and that will make it the exact opposite of this. I could have multiplied this one by -5. Whatever I choose to do, I've got to multiply everything in this equation by whatever number I'm multiplying it by. Every term has to be multiplied by that. If I multiply that one by -5, I have to multiply all of them by -5. I just chose this one because that's the one I picked. So here we go. This is -3R minus 3P. Is is equal to, what is that, negative 54? And then I'm going to bring this equation down so my eyes don't have to jump around. I'm just going to rewrite this one. Make it a little easier to see when I add my equations together. Step 2 says add the equations together. And I just rewrote this one so I didn't have to have my eyes jumping around. And this gives me 0 r's, which is 0. 5p minus 3p is 2p. 72 minus 54 is 18, I believe. And then I solve for the single variable. 2p is 18, divide both sides by 2, p is 9. I plug this into any equation that has two variables. So let's pick one. Here's a nice spot right here. The original equation, ignoring the blue stuff. Plug it in right there and I'll get r plus 9. Instead of a p, I've got 1 times 9, which is 9, equals 18. And I solve this one. Well, I subtract 9 from both sides, and I get r is also 9. How about that? If you buy 3 rose bushes and 5 pots of ivy and spend $72, and you buy 1 rose bush and 1 pot of ivy and spend $18, that means they have to be $9 a piece. So roses, $9, if I haven't made any mistakes. We'll see here in just a second. And what was the other one? Pots of ivy? Whoops. See if I can spell pots. Scroll a little bit, if it'll allow me to. Pots of ivy. I'm just answering the question now. Also $9. There are infinite combinations that will make either one of these true. But only one combination will make them both true. That's system. And let's see if that's right. Rosebush, $9. Pot of ivy, $9. Okay. So it all boils down to writing a couple of equations from your word problem, pull out a couple of equations, and then follow these steps. There's 6 of them. And by the time you get to step 6, you'll be looking at your answers. You can do this.